Okay, so in this video, it's a test review over going like rotational inertia and pulleys and tensions and all stuff like that. So first question is our rotational inertia total for this thing. It looks like this. It's one center axis point, and there's three different like distances away from this center axis point, and these are these three masses, right? These three solid spheres, and we're trying to figure out what the third mass is, and we know everything else. So what can we do? Well, we can use the rotational axis theorem, which states that the I total, which is given, is equal to the I of each individual one plus its md squared. So its mass times its distance, which is how far it is from the actual axis point itself. So what can we do? We can set this all up into one large equation. So our I total is 93.7, and that is going to equal to, now we can add each individual inertia up, and then plus its distance away times its mass from the rotational axis point. So first we can start with R1, which is I, for a solid sphere, our I equals 2 fifths mr squared. So 2 fifths, our m is 3.2, our r is 0.336, square that, and then we can add plus md. Mass is 3.20, and our distance away from the axis is 1.56, and you square that. That is our first one, and then we can add our next one, which is again 2 fifths. Our m is 1.6. Our r is 2.64. Square that, and then you add 1.60, our displacement, times our d 2.75. Square that. That is our second one, and our final one is going to be plus 2 fifths. We'll go down here. Plus 2 fifths. Our mass, which is unknown, m. Our r, 0.227. Square that. Plus m, unknown, times our distance squared, which is 1.73 squared. Now, you have this one large equation, and you can just plug this into numeric solver, and you should get around our third mass is equal to 6.8 kilograms. And that is how to do a question with that. Okay, our next question is pretty much a hollow, you have 8 different hollow spheres, and it's connected all by this one central axis point, and it is going to be sliding down this ramp here, and we have to figure out what the velocity is going to be. So how can we do this? Well, our first step is going to find our I total, so our rotational inertia total. So how can we do that? Well, we can find the rotational inertia for each individual one, and then multiply that by however many there are, which there are 8. So we can make this first step is 8, because there's 8 individual balls. And now we can do, and they're all separated at the same equidistant at 0.4755 meters away. So we can pretty much do this rotational axis theorem. So our hollow spheres, our I for that is 2/3, right? Times m, which each m is 0.525, times our r, which is 0.0416 squared, and then it is plus, and it's going to be md squared. So our m, which is 0.525, times our distance away, which each is the same, like I said, so 0.4755 squared. Now we can come up with that, and we can find our I total, which comes out to be 0.954 kilograms times meters squared. So once we have that, we can figure out what the velocity is by doing the equation. Our potential energy is going to equal our kinetic energy plus our rotational. So it's going to look like mgh equals 1/2 mv squared plus 1/2 iw squared. So we can just, memorize this equation, and then we have all the variables that we can plug in here. So what do? Our m is going to be 8 times our mass, because each mass, there's 8 of them, so we have to multiply 8 times 0.525 to get the total mass. Mg are 9.81, and h is 8.61. Sorry. And that is equal to 1/2 m, again, 8 times 0.525 times our unknown v squared, right? And then is plus 1/2 our I, which we just solved for, which is 0.954, times, now here's where it gets tricky. So it's times w, right? What is w? W is v over r, right? So we can substitute v over r into this. So v over, however, it's not this r, right? Because we can zoom in to this. So this is what this looks like. If we zoom in to like this one, for example, this is the r, right? And so where is this rolling? This thing is rolling, it's going to be rolling on this side of the wheel. So the distance from the center axis, this d, is from the center axis to the center of mass. So this is d. However, it's rolling on the edge. So this entire distance, right, from this point to the center axis is going to be d plus r, right? Because we have to figure out where it's rolling from. So what is d? Well, it's 0.4755 plus our radius, which is 0.0416. Now, you have this entire thing set up, and you just numeric solve for our v, and it should come out to 9.56 meters per second. And that is how to do a question like that.